Hello, my name is Brad Breiker. I'm here with Ronnie Islam, and we're from NextEngine. We're going to be demonstrating the NextEngine 3D desktop scanner and our associated Scan Studio software. As part of our demonstration, we're going to go ahead and scan this manifold that's set up here with the scanner that you see. The scanner, our NextEngine scanner, is a very small and portable scanner, and it can be set up easily on your desktop, as you can see. And the footprint of it is, if you stand up a sheet of paper upright and extrude it back 3.5 inches, that's the size of the scanner. So very portable, and again, you can set it up to your next to your computer very easily. Has worldwide power supply built in, has a USB connection, so very easy to set up next to your desk and your workstation. So we're going to go ahead and run a scan, and we're going to open up what's called Scan Studio. This is Scan Studio. See, very simple interface. We already have done a 360 scan of that manifold, which I'm going to come back to and show you features of Scan Studio. But before we do that, I'm going to go ahead and run a bracket scan of the object itself. In doing so, there's some setup that we need to do, and this is a very simple and easy setup. There's 3 scan modes. There's a 360 mode, a bracket scan, and a single scan. If you got it set up to a 360 scan, it's going to scan around the object. In this case, it's going to run 6 scans because we have division set to 6. It's going to move the turntable at 60-degree increments around, and for a total of 360 degrees. So I'm going to go ahead and go back. The bracket scan is also the angle which you scan is based on the division. So we're going to be setting this to a bracket scan, and the angle which we're going to move the turntable is still going to be 60 degrees based on divisions of 6. If I had set this to 12, it would move the turntable 30 degrees. So I'm going to go back to divisions of 6 because that's what we want to do for this object. If it had more occlusions, we would set the object most likely to divisions of 9 or 12 to get more of the occluded areas. We have 2 scan modes, what's called a macro mode and a wide mode. In this case, we're running in the macro mode, and this is essentially about 7 inches from the front of the scanner. And our depth of range is from 5 to 9 inches. If you have it set to the wide mode, that's going to scan further out, and I can click on this. It's going to scan from around 15 inches to 22 inches, and the focal point is nominally set to 18 inches. I'm going to go back to our macro mode. We have 3 speed settings, and standard speed setting is what most people use. You can do a faster scan and collect fewer points, or you can run a fine scan and collect more points. The faster scan is obviously going to be faster. The quick scan is going to be slower in collecting more detail of the object. When you set up your object, there's 3 very important things to note. There's the prep of the object. So in this case, we prep this object. We have a little powder pin that comes with the device, and you can see in here this little powder pin. I would dispense powder on the object in prepping it. We also have to make sure that it's in the right depth range, and I had mentioned that nominally you want to be set to about 7 inches from the front of the scanner here in the macro range. And the last thing is, in this surface settings panel, this is your exposure. So if the object is light, you want to underexpose the object. You want to bring the slider all the way to the right. If it's dark, you want to overexpose it and essentially have as much light on the object as you can. In this case, we're going to go ahead and scan at about 70%. We're going to set it to a surface of matte. You have both matte and shiny because we've already coded this, so a matte surface would be fine. And then we have decimation and some smoothing settings as well. The last thing we're going to do before we scan is do what's called a region of interest selection. And the region of interest selection is going to define the area that you want to scan. If you didn't set this, it would scan the whole field of view. But if you just want to scan a certain area, you can set this region of interest. So that's it. That's a very simple settings panel. We got our scan set up. I got my bracket set up. I'm going to go ahead and run scan. The fluorescent lights illuminate the object, and they are going to do a 2D capture. And so you can see from the video here that the fluorescent lights are illuminating the object. So we got our object set there in front of the scanner. Our 2D picture is done, and now the lasers will turn on, and the lasers are going to sweep across the object. Now there's 4 lasers at each position, a total of 8 lasers in the scanner.
So this is very important. It's part of our patented technology and a big differentiating factor of our technology over other digitizers. The 4 lasers give you what's called cross-validation or cross-sampling. For every point that we capture from 2 or more laser stripes, and we're able to cross-validate those points to verify where those points are. So once this scan finishes, we're then going to show what Ronnie has opened up here is a completed scan already. And what we've done to do this little manifold piece, we had set it in 2 different positions. The first position was the upright position. We scanned it 7 times around the object, and you can see the different thumbnails that were captured down below. What you're seeing on the rotating screen is a compilation of all those scans, basically the 7 scans put together. So that was one 360 which had 7 different scans going around it, and we collected those scans. Now we then orientated the manifold in a different position. You can see that we kind of laid it on its side, and then we collected again 7 different scans going around this. So we did 2 360s to capture a large part of this object. Now it's not going to capture everything. You're still going to have maybe a few occluded areas. When you look at this and look around the object, you may see a few areas that it didn't capture. Now we have some great new tools that allow you to hole fill, but most importantly we have what's called a fuse button, and we've already fused this scan here where Ronnie's going to highlight that. And what fuse means, it basically brings those 2 360s together, and it blends it all together so you see one nice uniform mesh. There's no overlapping mesh. It's a very clean mesh. And so you can see, for instance, on that MB what Ronnie has there, look at the detail it maintains. It hasn't thrown away any points there, whereas their surrounding areas, it did intelligently remove data. So what fuse does, it does 3 different things. It basically blends everything together, it optimizes the mesh, and it hole fills in areas where you had maybe some slight occlusions that you didn't capture with the scanner. And Ronnie's going to point to the button of the fuse button up top in our toolbar. This is one button does all this. So again, backing up with the scan procedure, we did 2 360s. The first 360 was a family of A. You can see the A family. The second 360 was a B family, and then we brought those 2 360s together by fusing them. And this is again a one button operation where we fused everything together to get the final model. Okay, so we finished up that showing you the 360 there. Now we're going to run back to the bracket scan here, and we're on this. We finished the first scan of the bracket. Remember, a bracket does 3 scans, and so the other 2 scans of the bracket have come in there too. So if Ronnie highlights, you can see the 1 scan there and the 3rd scan. So what Ronnie's going to go ahead and do, now that we have the 3 individual thumbnails, he's going to go ahead and we're going to trim these up. So we're going to go to the polish menu, go to trim, and you can see that we have some areas of the turntable that we captured there. So Ronnie's going to go ahead and basically trim those out. You have the option, he picked on the square there, you also have the option of the circle, but what we're going to be doing is removing data because we got the plus highlighted and the square. So Ronnie's going to highlight those, and so you can see this is a pretty fast process. He just highlights it, and then of areas that he wants to remove, and then it's just like a paint tool, and then he's going to say click on trim, and it's going to remove that data. So that's the first one he's done. He's going to do scan number 2 and 3 as well. And you can do this while you're scanning. You don't have to wait until the scan is done. Basically you can trim the individual thumbnails while you're scanning, which is a nice feature. So basically when you get done with your scan, you're ready to go ahead and align, merge, and finish your scan. So it saves time to trim while the scan is taking place. So once the trimming is complete, what we're going to show you next is the alignment of the 3 bracket scans. And so typically what you want to have is fiducials or markings on the object that you can reference to in your alignment. So the alignment is very simple. Basically what Ronnie's done here is he's shown that we have the 3 scans. You can see that the first scan is in the left quadrant and the second scan is in the right quadrant. And so there's overlapping data there, as you can see, and we have markings on the object, and we have 3 pins. What you're going to want to do is drag and place a pin to a known area that you can easily mark on both scans. So Ronnie's dragged the red button to that X on the X area that you see, and we're going to place 2 more pins for a total of 3 pins. So once you have an alignment completed for the first scan, you don't need to do it for your second 360 scan. So if you don't move the turntable or the scanner, what we have intelligence built into the turntable that's going to automatically record the coordinate system between the turntable and the scanner, so that when you do run a second scan, whether it's a bracket or a 360, it's going to automatically align those scans for you. So the last step Ronnie's going to do here is run attach all, and you'll see that under align you can see that there's a little section called refine alignment. What that is a geometric algorithm that locks in to the geometric features of the object. So when you're first doing your alignment and you place those 3 pins, it doesn't have to be super accurate, because once you're within 100 thousandths, our refine alignment algorithm kicks in, and it's basically going to get everything much tighter. And you can see the green bar there, how tight it did get in the alignment there. So so what Ronnie's going to do here is clean up those few extraneous points, and then he's going to go ahead and fuse the scans. And so again, if you remember from our polish menu, that it's very easy to go down and clean those scans up. You can do your cleanup on once it's completely aligned and when all the scans are together. There's a lot more data there, so it's more processing time to deal with, but it's probably better to scan at the individual thumbnail level, because it's going to be a lot faster and easier for you to trim. So Ronnie's finishing up his trimming here. So the last step we're going to do now is basically fuse the scans together. And remember that the fuse is going to do 3 things. We got a few areas there. If you look, there's a few occlusions that we missed, and so the area there, and so what it's going to do, it's going to merge the scans together. It's going to hole fill and do intelligent decimation. So now we're ready to fuse, and so we're going to go to the fuse panel here, and there's some settings that we have in here. You can fill all holes, or you can set the circumference of the hole that you want to fill. So Ronnie's going to go ahead and set this. So again, this is intelligence. It's meant for a very quick 1-button fuse where you can hole fill, you can do your texture blending, you can do your automatic decimation, and again do all the merging of the scans. So this is a very nice, clean, elegant solution, because it does everything for you with a 1-button click, so you don't have to do all the steps individually. So once we finish this, we're going to go ahead and show you the CAD tools, and we're going to auto surface the complete 360 model. But before we do that, we want to show you the results of this, obviously, once it's fused. And so it's going to be a very clean model as we had shown you with the 360. Essentially, you're going to get those same results from these 3 scans. Now that the fuse is done, we'll look at the results here. So you can see that those holes that we had in the data before are hole filled. So, and again, this is all through the 1-button hole fill. 1-button fuse button. If we look at that MB, where that's a particular area I want to zoom in on. If Ronnie goes to the mesh mode, you can see how clean that is in terms of the final results here. And so this would be the final step of getting to an STL file. So essentially now we could save this out as an STL file. And remember, this is just a mesh format. It has no intelligence to it. And what we're going to do now is go to the 360 scan that we had done before, and we're going to show you how to save out as an IGES or a step file. What we had done before, if you recall, with the two 360s, we ran the fuse as well, and we showed you the results of this. So what we're going to do is go ahead and run what's called an auto surface. So if we go to our CAD button up top, you can see there's 4 selections up top, and the third selection in is called surface. So we're going to click on that, and what that is essentially we're creating surfaces on the object, and those are intelligent surfaces. We're doing what's called an auto surface. So for this object, we're going to put in around 700 surfaces, and what we're going to do is just run what's called a surface. So we can once we have our surfaces defined, we're going to go ahead and run the auto surface. And what this does, it basically overlays that NURB surface onto the scan mesh. And so this is a very important step because number one, it seems very simple, but yet there's a lot of intelligence going on behind the scenes here with the software. So what we've done with this in Scan Studio Pro is we've offered the ability to very quickly get to a NURB surface. And you'll see that the translation between an STL file or a mesh file in going to an IGES file, we still maintain a lot of the detail, and so that's a key point, because essentially the translation accuracy is typically around 0.1 mm or less when we go from our NextEngine mesh file, the SCN file, to a IGES file, and we'll see the results here. So what you can do with the IGES file is then you can bring that into any version of SOLIDWORKS. You could bring it into SOLIDWORKS Office, Office Professional, or Office Premium. And why this is so nice is that you don't have to have SOLIDWORKS Office Premium to bring an IGES in. You can have SOLIDWORKS Office, Office Professional, or Office Premium. What the IGES allows you to do is basically reference to the mesh. You can reference to it in SOLIDWORKS. You can use it in your assembly process. You can shell it. You can cross-section, and so forth, and basically use it as reference in your design. Now, if you want the full featured model, that's what we're going to be showing next. The RapidForm team is going to show you how the RapidWorks tools basically create a full featured model that you can then manipulate in SOLIDWORKS. So what we have is basically now the menu. If you go to www.nextengine.com, you can see that we have 3 product solutions available from a software standpoint, where we have the core software, we have Scan Studio Pro, what we're showing here, and then of course what we have with RapidWorks. And with Scan Studio Pro, we have some other tools as well. We have a spline out tool. We're not going to have time to demonstrate that to you here, but you can basically create splines and very quickly and easily get spline data from your object and save that out as an IGES or an IGES or a step as well, and bring that into SOLIDWORKS, and then you can loft to the surface or use the SOLIDWORKS boundary surfaces to create the surface of your object. So now this is complete. So again, what this is showing is a graphic representation of the IGES file. So let's go to that MV area again to see the details, and you can see how well it maintained the detail and integrity of that area when we went to different file formats here, going from again a mesh file format to the IGES file format. And so if Ronnie goes to File Save As, you can see now that we could save this as a IGES file or a step file. And so you can either do the one button, or you can do the drag down menu and do a File Save As. So whatever you wish to do. So that's essentially the summary of our presentation, and we're very excited to present this solution to the Fisher Unitech customers, and we thank Fisher Unitech very much for allowing us to host this presentation. And now we're going to turn it over to the RapidForm team, and they're going to show you RapidWorks, which takes the same model and again creates a full feature tree of the object.